Well, in the last class, I talked about standard cells, and to calculate the EMF of any non-standard cell, I said that we needed Nernst equation. Nernst equation is an equation derived from thermodynamics. Derivation is not necessary, but what is Nernst equation? For any chemical reaction of this type, where metal ion is receiving electron to become metal and undergoing reduction, we can write Nernst equation in this manner. This is the electromotive force of any cell which is non-standard equal to standard EMF of cell minus RT divided by NF ln product U product divided by reactant U reactant. Now you know the contribution of metal in aqueous solution is nothing, its activity is 1, so you can write 1 equal to 1. So now RTNF, RTNF, R is universal gas constant, so 8.314314 joule per degree Kelvin per mole. The value of T will remain 25 degrees Celsius, 298 Kelvin. Value of F, which is 1 Faraday, is 96500 Coulomb. N is the number of electrons given or taken, exchanged. So when you put all these values, you will get 0.0592 divided by N. And do not forget that ln has been converted into log, so 2.303 RT. So what will happen? EMN plus by M equal to E naught MN plus public M minus 0.0592 divided by N. Now log 1 by Mn plus. So this is the equation, Nernst equation for this kind of reduction reaction. Now if we take Daniell cell equation, Daniell cell or simple voltaic cell or galvanic cell, whatever you call it, zinc Daniell cell equation was of this type. You will write now non-standard cell, which means copper is not in 1 molarity, the concentration of copper is not in 1 molarity, concentration of zinc is not in 1 molarity. Then the EMF of cell will be equal to standard EMF of cell, which is already known to us. This is 1.1 volt. We calculated this in earlier video, minus 0.0592 divided by, instead of N you can write 2 because you can clearly see that 2 electrons have been exchanged, log, now product, the concentration of Zn plus 2. You can avoid copper because the activity of copper, since it is a solid, is 1. Denominator reactant Cu plus 2. You can avoid zinc because the activity of zinc is 1 because it is in solid state. This is EMF of cell. This is standard EMF of cell, which is 1.1 volt. We already calculated that. Now if the concentration of zinc is given, say 0.1 molar, then you can put the value of 0.1 molar. If 0.01 molar of copper sulfate is given, you can put this value. Now this is a question based on Nernst equation. We can solve it. It appeared in 2015 higher secondary examination. Write down the appropriate Nernst equation for the following voltaic cell. The cell is given here, and calculate the EMF of cell at 298 Kelvin. First, you have to make an equation taking place for this cell. Second, you have to calculate standard EMF of cell using the values given here. And the third, you can convert that standard EMF into the EMF of cell using Nernst equation. Now, Fe is converted to Fe plus 2. Ag plus is converted to Ag. So this is the cell equation. Now, as we know, E naught of cell equal to E naught cathode minus E naught anode. Reduction should take place. Reduction should be taken into consideration. Reduction. So E0 cathode. This is cathode. Ag plus oblique Ag minus E0 anode. Iron is anode here. So Fe plus 2 oblique Fe. What are the values? 0.8 minus 0.44 volt. So what will be the value? 1.24. This is the standard EMF. Standard EMF of cell. Cell equation is here. Standard EMF of cell is here. So how will you write Nernst equation now? E cell, you have to write E cell equal to E naught cell minus 0.0592 divided by, okay, let us balance the chemical equation. 2. You can write 2 because 2 electrons have been given or taken, exchanged. Log Fe2 plus, you are not writing silver, Ag plus. Remember, this coefficient will go to the power. You are not writing iron because it is in solid state. You are not writing silver because this is in solid state. Any coefficient before the ion will go to the power. Remember that. Now you have E0 cell equal to 1.24. So 1.24 minus 0.0592 divided by 2 log the value of Fe plus 2. Concentration of Fe plus 2 is 0.002. So 0.002. Silver concentration is 0.02. 0.02 square. So equal to 1.24 minus 0.0592 divided by 2 log 2 into 10 to the power minus 3. You can write 2 into 10 to the power minus 3 divided by 2 into 10 to the power minus 2 into 2 into 10 to the power minus 2. 0.02 is equivalent to 2 into 10 to the power minus 2. There is a square here, so we are writing it twice. So cancelling all this, 0 here, 0 minus 1, everything, what you will get? Equal to 1.24, 0.0592 divided by 2, you will get log 5. 1.24 minus 0.0592 divided by 2, and the value of log 5 is 0.6989. Now calculate using your calculator, you will get 1.219. This is the answer, and this is the EMF of cell. The value is at 298 Kelvin. You just have to see the temperature. You don't have to use the temperature anywhere in the expression. If it is 298, 25 degrees Celsius, then the temperature hasn't been changed. Well, there is a simple question here, 2013 as secondary examination. Explain the feasibility of the following reaction. Sn plus 2 reacting with Cu, giving Cu plus 2 and Sn. What does feasibility means? Does this reaction actually occur? Can copper displace tin from its salt? Is it possible? The values are given here. From the values given here, we can make out. Well, see, the value of copper is positive. The value of tin is negative. The value of tin is smaller and the value of copper is higher. The smaller number will remain on the left. Left means lone formula will be applied to this. Lone, L stands for left, O stands for oxidation, A stands for anode, and N stands for negative. You just remember O stands for oxidation. So tin must undergo oxidation. You can see at the reaction whether tin has undergone oxidation or not. Tin, Sn plus 2 is becoming Sn. Is this oxidation? No. Plus 2 is reduced to 0. Plus 2 is reduced to 0 means Sn plus 2 is undergoing reduction here. But it was supposed to undergo oxidation according to the value given here. So this reaction is not feasible. Not feasible. Now what the feasible reaction would be? Copper would be plus 2 copper Sn arrow Cu plus Sn plus 2. This should be the feasible reaction, where Sn is undergoing oxidation, O, and the copper is undergoing reduction. Tin is oxidized, copper is reduced. This should be the actual reaction. This is feasible, but this is not feasible. Now let us find out the relation between standard cell potential. Cell potential, which is nothing but standard EMF of cell, represented as E naught cell, and the relation between standard EMF of cell and equilibrium constant. Do you remember that? Equilibrium constant of any chemical reaction is usually represented by capital letter K. We know from thermodynamics that delta Z, change in Gibbs free energy, and the Gibbs free energy is in standard state. Change in standard Gibbs free energy, standard free energy you can call it. In thermodynamics, if the value of this is negative, then the reaction becomes spontaneous. It was equal to minus NF E naught cell. N, number of electrons, number of moles of electrons actually, F 96500 coulomb, it's 1 Faraday, E naught of cell is there. And we also knew that delta Z naught equal to minus RT ln K. Now if we combine these two equations, then we get minus NF E naught cell equal to minus RT ln K. Minus minus cancel, E naught cell equal to RT by NF ln K equal to, you're converting ln to log to the base 10, so 2.303 RT by NF log K. So E naught cell equal to, you know, the value of 2.303, all this taken together will become 0.0592 divided by n log K. So this is the relationship between standard cell potential or standard EMF of cell and equilibrium constant K. Let us solve this question. This was in 2016 higher secondary examination. Determine delta G naught, free energy change, standard free energy change. Determine delta G and the value of the equilibrium constant for the following reaction occurring in an electrochemical cell at 25 degrees Celsius. The equation is copper is reacting with silver nitrate to give cupric nitrate and silver, Cu plus 2Ag plus aqueous 2A. First you have to calculate, since our equation is E naught cell equal to 0.0592 divided by n log K. So E naught cell you have to calculate. How would you calculate that? E naught cell equal to E naught Ag plus divided by Ag. E naught of cathode with reduction minus E naught of anode with reduction. Now if you compare the value of copper electrode and silver electrode, the value of copper is lower, 0.34, 0.8. The value of copper is lower than that of silver. So the copper will follow Lone rule. So copper will undergo oxidation. Oxidation means it will remain on the left hand side. It will remain on the left hand side means it will be anode and it will be negatively charged. On the left copper, on the right silver. So to get E naught of cell or standard EMF of cell, you will be subtracting anode from cathode. Anode from cathode. Higher minus lower. 0.8 minus 0.34. Now it will be 0.46 volt. So this is the standard EMF of cell. Now we have been asked to calculate delta Z naught, which is equal to minus NF E naught cell minus N. How many electrons are there? How many electrons have been exchanged? 2. F is 96500 into E naught of cell is 0.46. So this is You can calculate easily with the help of calculator. 88780. Remember, the unit will be joule because it's energy. Now, how do you calculate equilibrium constant? Using the formula E naught cell equal to 0.05. What was the formula? N log K. This was the formula. That is 0.46 for standard EMF, 0.0592 divided by 2 for N log K. Now log K equal to 2 into 0.46 divided by 0.0592. What will be the value? If you calculate this, this becomes 15.56. Now, how do you find log K? K equal to anti-log of this. K equal to anti-log of this number. In scientific calculator, you will have to press shift log and this number, you'll get anti-log. So then the value of K will become 3.68 into 10 to the power 15. This is the answer. Let's see this. This is another question from 2019. Write cell reactions, and you have to write cell reaction and calculate electrical work. Now what is electrical work? This is delta G, electrical work, obtained from the following cells at standard conditions. Now comparing these two values, you can clearly see that magnesium will be on the left hand side and it will follow lone rule. Magnesium will undergo oxidation and it will become anode. So on the left, magnesium, on the right, silver. So cell reaction, magnesium became Mg plus 2, silver Ag plus became Ag. Number 2 you have to do. Finish. Balance the equation. This is the cell reaction. Now to calculate Z, since you know delta Z naught equal to minus NF E naught cell, you have N equal to 2, F equal to 96500. You have to calculate E naught of cell. How do you calculate that? E naught of cell equal to E naught of cathode reduction minus E naught anode reduction, which means E naught, this is cathode, Ag plus oblique Ag, E naught Mg plus 2 by Mg. You put this value 0.8 minus 2.36, 316 volt. Now E naught of cell equal to 3.16 volt. You calculate this with the help of calculator and just write joule. That will be your answer. I think you understood the problems based on Nernst equation and the relation between standard EMF and equilibrium constant. Try to do as many problems as possible from your book. Next time we'll be doing electrolysis, Faraday's laws of electrolysis and conductance. Thank you.